Hi everyone. In today's lesson, we're going to talk about summation, but this time we're going to use something called sigma notation. So sigma notation is when we have a series that is the sum of the terms of a sequence. The symbol sigma, called sigma, is used to indicate the sum. So when you see this sign, this means to take the sum of any sequence. And usually there are going to be some other numbers there. There's going to be a value here on the bottom, which is our start value. There'll be a value here on the top. This will be my end value. And then there's going to be some sort of formula in here, which is really our sequence formula. So these are the three components that make up a summation. So basically, here's an example. It just says here, given this formula, write the series in expanded form and then evaluate the series. So when I say series, what I'm talking about is a sequence that uses plus or minus in between so that we can add them up. So for example, let's just scroll down here a little bit. We have our sigma from k equals 2 to 7 of 2k plus 2. So as we said before, this is going to be my start value at k equals 2. And then this is going to be my end value at 7. So what you're going to do to find each of the terms of this series is you're going to plug in 2 for 2k plus 2. We're going to do that first. So let's plug in our value, then add 2. So we're going to start at 2 and go all the way up until we end at 7. So we're going to do 2 times 2 plus 2. Then we're going to do 2 times 3 plus 2. Then we're going to keep going until we get up to 7. So 2, 3, 4, 5, 6, and then one more. So 2 times 7 plus 2. So what that was is we started at 2, we ended at 7, we went from 2 to 7. So now all you're going to do now is figure out what each one of these values come out to. So 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10, 10 plus 2 is 12, 12 plus 2 is 14, 14 plus 2 is 16. So each one of these, the 6, the 8, the 10, the 12, the 14, the 16, those are the terms of the series. So it says write the series in expanded form. So what expanded form means is that we're going to take each of these and put a plus sign in between them. So we've got 6 plus 8 plus 10 plus 12 plus 14 plus 16. So this, what you just wrote out, all of this is your series. And then to evaluate our series, which is this, the evaluation. So evaluate the series means evaluate the sum. So literally all you have to do now is put into your calculator all of these terms added together. So take a minute, do that, pause the video, and hit resume when you're ready for the answer. Okay, so you should have gotten 66. So 66 is the sum of all of these terms. All right, let's take a look at example number 2. So same thing goes. They want us to write the expanded form and then evaluate the series, but this time they're giving us another formula. So they're giving us the sum from I equals 2 to 4 of I squared. And they also have this 5 in front. So first, let's analyze a couple things. We still have our start value to be at 2. We still have our end value to be at 4. Now this time we have this 5 in front, and the 5 is attached to this sum by multiplication. So what it actually means for you to do is you're going to take this sum, figure out what the sum is, and then multiply your answer by 5. So basically, 5 times whatever the sum of values are. So we're going to do the same thing as before. We're going to use our sequence formula, start at 2, end at 4. It's okay that it's an I and it's a different letter. I can change whatever letter I want it to be, so we'll just plug in for that letter. So we have I squared. So we're going to plug in starting at 2. So 2 squared, 3 squared, and then 4 squared. 2 squared is 4, 3 squared is 9, and 4 squared is 16. So my expanded form, same as before, is just term 4 plus the second term plus the third term. And then the evaluation, the actual answer, the sum, is just adding them together. So take a minute, pause your video, and type in 4 plus 9 plus 16, and then hit resume when you're ready for the answer. All right, so you should be getting 29, and that would be the sum. But what we have to make sure we do is we have to multiply this sum by 5. So the answer is technically 5 times the sum of 29, which gives you 145. So the answer to this question is 145, not 29. This is the evaluation of the sum, and then we have to multiply my answer by 5. All right, cool. Let's take a look at the next page. Okay, next. So I could ask you in example number 3 to use sigma notation to represent this sum. So remember, we always have our sigma, right? We have our start value at the bottom, we have our end value at the top, and we have our sequence formula here. So that's what they're asking us to do. They're asking us to use sigma notation, right? This little symbol here means sigma, to represent this formula. So let's look at the steps. So first we have to determine whether the series is geometric or arithmetic. So by looking at this one, how are we getting from 4 to 10 to 16 to 22? So it looks like from 4 to 10, we're going to add 6. So let's keep seeing if that works. 10 plus 6 is 16. That works as well. So we know this one is an arithmetic sequence with a common difference of 6. So we're nicely now going to look at step 2. Determine the formula for the nth term. This will be our sequence formula. So we're going to use the formula that we've learned previously. A sub n equals a sub 1 plus n minus 1 times d. So my first term of the sequence or series is 4. We're going to leave n alone. And my common difference is 6. So if we distribute the 6 in, we get 4 plus 6n minus 6. Combining like terms, we'll get 6n minus 2. So this is my sequence formula. So to finish this off, all we have to do now is put it together. Here is my sigma, and my sequence formula is 6n minus 2, and my start value will always be 1. So since I used n, we have to use n here. So n will be 1, and we just need to count the terms. 1, 2, 3, 4, 5, 6. So there are 6 times that we will be adding, so the 6 will go on top. That's where I end, and that would be my final answer. So if you want to write that this 6 up here is just the number of terms, right, that we're adding together. So we started at 1, 2, 3, 4, 5, and 6. Okay, let's take a look at example number 5. And this will be the last one. So this question's a little different, only because they're giving you 1, 2, 3 terms, and then they have a dot, dot, dot up to 64. So we have to do a couple of things here, right? We know we have to write this in sigma notation. And we know that n equals 1 will always be the start value, and we need some sort of sequence formula. So let's figure out if this is arithmetic or geometric. So I know that 1 times negative 2 will give me negative 2. Negative 2 times negative 2 will give me 4. So that seems to work. So I'm thinking this is a common ratio. So my r is negative 2. So I need my sequence formula. To find my sequence formula, I'm going to use a sub n equals a sub 1 times r to the n minus 1. So my first term is 1. My common ratio is negative 2. And I'm going to leave the n minus 1. If you want to simplify it just a little bit more, you don't need the 1 in front, so you can just say it's negative 2 to the n minus 1. And that will be my sequence. So if we knew how many terms it would take us to get to 64, then we're good, right? We need number of terms, not 64 goes there. How many values do I have to add up to get to 64? So we need to find that. So in this scenario, we're going to use our explicit formula again. So we have a sub n equals -2 to the n minus 1. So I know that my term that I have at the end is 64. So that can go in for a sub n. And I want to figure out how many terms is it going to take me to get there. And those terms are called the n values, right? N is the number of terms. So you can log both sides if you want, or you can just take a look at this and play with common bases. So since I have a base of -2, I'm just going to go in my calculator, play around with the powers until I get 64. So take a minute, pause the video, and try to see if you can figure out -2 to what power gives me 64. My hint is to make sure the -2 is in parentheses, otherwise you might get the wrong answer. And then you can hit resume when you're ready. All right, so I played around with it until I got 6. So -2 to the 6th equaled 64. And I want to set that equal to -2 to the n minus 1. And we know that when we have a common base, we can set the exponents equal to each other. And we add 1 to both sides to solve for n. So n equals 7. So that must mean it takes 7 terms for us to get to 64. So the 7, the number of terms, needs to go on top. So this would be my final answer. So questions like this, where they don't tell you how many terms, you just need one more extra step to use that explicit formula to help you find the number of terms. All right, that's it for today. If you guys have any questions, now is a good time to jot them down. Otherwise, we'll see you in class tomorrow. Have a good night.